Good morning, everyone. What we're going to jump into today is I'm slowly building out some coursework for Malware Village for some upcoming events and stuff. So I'm going over some basic exploit development stuff and stuff to put together a short class. So what I'm going to do today, I've just called demystifying the stack. Excuse me. So I'm going to jump into and show you how a stack's created and how to find all the variables on the stack from a C binary. So we'll compile the binary, we'll haul it apart in normal GDB, no PETA or anything fancy, and I'll show you how to find everything on the stack. So we'll have a lot of fun. So let's get over to the important stuff. I'm using MX Linux, but you can use any 32-bit Linux you want. Up right here, I have the C program already written up. We have an int A, it's a 69, and I tried to be so childish as I possibly could. And int B 666, and the character string, my string with fuck, and then a return to libc main at the end. So first things first, we'd have to compile this. So we'll get to our working files, cd binaries, lsdsl. As you can see, I've already done this, but I will show you how to use GCC. So use GCC. The first thing, no stack protector. And for these beginning ones, we don't want stack cookies turned on. If you want to see bypassing those, you can check out my videos on YouTube. And no pi. Now we do stack.c and we output to stack. And there we go. So now our file is compiled. So we can go up here to binaries. And as you can see, here's our compiled program. So what I'm going to do is fire this up. I'm going to show you how stacks are created and then how these variables are stored in the stack and how to find things like this return address, this argument count, this argument vector. So hopefully by the time you walk away with this, you'll have a basic understanding of stack creation and how to find these variables on the stack. Okay, so I'm going to keep this open here. And we're in binary. So we're going to open up GDB. We're going to hit Q for quiet the comments at the beginning. And let's open up stack. Okay, so first things first, disassemble the main function. And now let's have a look. So this is the assembly code for this right here. So the first thing that happens with stack creation is the base pointer is pushed onto the stack. You can see that right here. It says push EBP, which is the base pointer. Okay, so we just pushed a base pointer onto the stack. The next line here, we move the ESP to the same place as the EBP. So they're sitting at the exact same place in memory. And then the next, this is called a prologue, by the way, and this down here, which closes out, is called the epilogue. But this here is opening up the stack. And then from there, we subtract hex 10 from the ESP. So now the base pointer is sitting hex 10 below the ESP, and this is the full stack creation right here. And we'll jump in and we'll have a look at this, but I just want to explain it as we go too. Okay, so as you can see, we have a whole bunch of things added in here, but let's work through it. So what I'm going to do, I'm going to put a base breakpoint right here. Let's set up our breakpoint. And then I'm going to run the program, and I'm just going to put in an argument of, an input argument of just these A's. Okay, so the first thing I want to do, I want to display 34 words in hex from the ESP. So from the stack pointer, I want 34 words, and now each one of these here is a word. It's 4 bytes in 32-bit, a word is. So each one of these is a word. So now I have 34 of those. So I also want to display 3 of EIP, which is our index pointer. And our index pointer points to the next thing the program is going to execute. So this allows us to keep an eye on what's happening in the program better. And as you can see, we are at the first breakpoint here that I set at the beginning, and we're going to push the EBP onto the stack. So if I do print EBP right now to see where it is, as you can see, void 00. The EBP doesn't even exist. So there's nothing in this memory right now on this stack. So if I hit NI for next instruction, you can see now that push the EBP on. So like, let's have a look, push or print EBP, still 0. So let's hit the next. Right now, the ESP and EBP are moved to the exact same place up here. So like, let's print ESP. And as you can see, the ESP is at this address right here. So this right here is where both our base pointer and our stack pointer are pointing right now. And there's nothing in between them. So our stack isn't created yet. The base pointer and the stack pointer are moved onto the stack. Okay, let's hit next instruction. And next instruction is pushing 10, subtracting 10, sorry, from the ESP. So what we will do, so what's 10 in normal decibel? As you can see, it's 16 base, right? So it's subtracting 16 bytes from the ESP, and that's where the base pointer is going to go. So the stack pointer is going to stay up here, and we're going to do 4, 8, 12, 16, and then the base pointer is going to be down here. So let's hit next instruction. Let's hit print EBP, and as you can see, the EBP is at 018, exactly where I said it was going to be, okay? So we seen that last instruction, the subtract instruction, subtract 16 from the stack pointer. The stack pointer was up here. We subtracted 16, which put it down here. So here's our base pointer, and I'll do this for you for clarity. And as you can see, our stack pointer is at this address right here, just up above. Okay, so now our full stack is this right here. Next, we're going to start seeing things being put onto the stack. So let's hit next instruction. Let's have a look at what this here is. So next, we're going to see this here is going to be added to the EAX register. So let's hold it our calculator. And let's do, let's clear this, 2EA7. Okay, so next what we're going to do is move long 0x45. So let's hold our calculator. Sorry, I messed up there. Hold our calculator. 0x45, so let's do 45 in hex is 69. So this right here now is going to be our 69 being pushed onto the stack. And where is it going to be? It's going to be 4 hex from the EBP. So we already have our EBP here. We know that each one of these are 4, a word. So that for X45, which is hex for 69, should be pushed here at the next instruction. So let's hit next instruction. And next instruction. And as you can see, boom, here's our 69, which is this right here, and it's now on the stack. And as you can see, it was 4 hex from the base pointer. So here's our base pointer. Now there's our integer A. And we can also do print. Oh, No, it's not going to work right now. So next, what we can do is int b. So now int b is coming up next, and that is this right here. So our 666 is 29A in hex. so instead of saying Hail Satan that way, you can say Hail 29 alpha. And that's going to be moved 8 from the base pointer. So here's our base pointer. Here's where our integer a went, and that was 4 from the base pointer. So that would tell us that this here is where our integer b 666 is going to end up. Okay, let's hit next instruction. And as you can see, there it is. So now it has 69666. Now, if we load our string, let's have a look here. Whoops. I'm typing in my C. Now, something else we can have a look for here too is our return functions. So now this is, they're moving what was in EAX to 0xc. So that's 12 from EBP. So now our fuck is going to end up right here. So let's hit next instruction. And as you can see, there's our fuck. So what we can do, we can examine string, examine string, this right here. And as you can see, it says fuck. So what happened, the base pointer got pushed here, the stack pointer got pushed here. It subtracted 16 bytes, 10 hex, to put the base pointer here and the stack pointer here. It then started filling up the bottom of the stack with 0x45, which is 69. It then put 666, and then it put fuck. So that is how stack creation happens in assembly. It's not that hard, and the assembly code is really easy to read once you get a hang of it. Some other things I'm going to point out here is we have an argument count right here, an argument vector right here, and a return address here. So I've already shown you where these go on the stack. Where does the rest of this stuff go? Okay, so let's go with our return address first. When the program hits return, it returns libc main, and that's where the program exits. So what we'll do is let's do print our EVP, and that's going to show it right here. So the 4-byte, the word right next to your base pointer always is the returned libc address, and that's this right here. So what we can do, just to confirm it, let's examine the words of hex right here at this address. And as you can see, libc start main. So it's a return to libc start main. And I'll probably do a video on this to demystify this because it's pretty simple too. But just know that that is the return exit right there. Next, we have argument count and argument vector. Now, knowing where these are really important because this is where you would overwrite the return address is where you put system. The argument count, which is this here, is where you would put your exit, and then argument 2, the argument vector, is where you would put your bin sh string once you get into taking over the system via buffer overflow. So this is why we really need to know where all this stuff is. So as you can see, the argument count is 2. Now, the reason it's 2 is because the name of the program is number 1, and our A's we put in are the second argument, okay? So that's the 2 arguments we have going on with this. And if we look at this is the argument vector right here, the char argument vector. But what we can do, we can examine this. And as you can see, this points to a string here. So what I can do, examine, let's do 2 strings because it's 2 arguments. And let me pop this in. And as you can see, there's our 2 arguments. So here's our argument count, and here's our argument vector, which stores the 2 arguments, which is the name of the program and our input. So that is the stack demystified. That's the whole thing. So hopefully just with this little video here, you can compile this and have a look at it yourself and see how things fill up in the stack. And yeah, that's pretty simple. So what I'm going to cover over the next couple weeks is going through all these basics and putting together a program for myself for some projects I'm working on. So look forward to more beginner videos over the next little while, and stay tuned for some crazy shit too. Okay, so thanks for everything, and I shall chat with you guys later. Please share. Bye.